Welcome to Cobweb Maths. I'm Craig Grant, your host. This is the third video in the series that deals with complexity in basic geometry and doing it in a simple way. In this video I'll cover angles at a point. We'll also cover isosceles triangles and equilateral triangles, and I'll also deal with parallel lines and their angles. And the last thing I'll do is I'll work through another complex problem and divide it into simple parts to make it easy to work out. Angles at a point add up to 360 degrees because if you start here and you rotate all the way around there, you do a full turn, and a full turn has 4 right angles, which is 360 degrees. So angles A, B and C, when they're added together, A plus B plus C is equal to 360 degrees. Isosceles triangles have 2 equal sides, and that means that the base angles are equal. An equilateral triangle has 3 sides equal, and all the angles inside here will be equal to 360 degrees. Right, let's look at parallel lines. These 2 lines are parallel, there and there, and if we look at this up here in the middle, it's exactly the same down there. So you have an acute angle and an obtuse angle. If that angle was 80, that's 80, that's 80, and that's 80, and that'll be 100, 100, 100, and 100, because 100 plus 80 is equal to 180, and they're on a straight line. Now we'll look down at corresponding, which is next, and alternate, and I'll move the camera. With corresponding angles are equal. You have 4 pairs of equal angles. There's 1 and 1, 2 and 2, 3 and 3, 4 and 4, and they are like sliders. They slide, that angle slides down onto that one. That angle there will slide down onto that one. That 3 will slide down onto that 3, and that 4 will slide down onto that 4. So they're like sliding doors, and that's the runner down there. Now we're going to have a look at alternate angles. They're just 2 pairs. That and that, that and that. If that was, say, 120, that would be 120, and that would be 60, and that would be 60. Now the way you remember it is a car alternator rotates. If that was if you put a centre of rotation there, that angle would rotate round onto that one, and that one would rotate round onto the other one. And the last one we've got to look at is co-interior angles. Alright, co-interior angles add up to 180 degrees. That angle and that angle add up to 180. That angle and that angle add up to 180. If that one was 80, that one would be 100. If that one was 100, that would be 80. And the way I remember it, I talk about a couple of old men being in a room, and it's a funny room like this. And the person who sits here is 80 years old, and that person there is 100 years old, and the sum of their ages is 180. So if that person there was 70, then that person there would have to be 110 years old. And that's the way I teach my students, so they'll remember it. Well, right, here's a complex question. It's got a couple of parallel lines in it. It's got a straight angle here. It's got a triangle here, and the triangle is an isosceles triangle. And they give you one angle, that's 50 degrees. So that's where you start, and you look at angle A. Now, what I've done is I put the stuff in red, and see that there's the 2 parallel lines, and that's the transversal, and that's 50, and that must be 50, because that angle will slide straight down onto that one, and they are corresponding angles. Now when you get parallel lines and corresponding angles, the corresponding angles are equal. So you put down that's going to be 50, and the reason will be corresponding angles and parallel lines. Now when you look at B and C, B and C must be equal to, I'll put it over here, B plus C must be equal to 130. Right? Because 130 plus 50 is 180, and they're both equal. So you just halve 130 and you will get 65. So B and C are both 65 degrees. Right? And the reason is it's an isosceles triangle. Then you go to D. Now you know that that angle there is 65, so you've got 65 and 50, which will give you 115. And now we know that those three angles there must add out to 180. You have to add on 65 to 115 to get 180. Well, 65. It's the same as the other one. Yeah, it is interesting. Anyway, and the reason for that is angles on a straight line. And there we have the complicated question. All you had to do was be able to see the corresponding angles first, then focus on the triangle in here, and then focus on here on angles on a straight line, or three things.